Hey guys, in this video we are going to see how to convert a complex number from rectangular form to polar form. Now let's look at this given problem. Here this question is asking, given a complex number w is equal to x plus jy, the complex conjugate of w is defined in rectangular coordinate as w asterisk is equal to x minus jy. Use this fact to derive complex conjugation in polar form. Okay, and we know that in rectangular form, if you look at the standard form, that's going to be a plus jb, and if we convert this one into polar form, that's going to look like this: r angle theta, or in other way we can express this one as r e power j theta. So there are two different ways to write this one, right? Now let's look at the given one. Here we are not trying to convert this given complex number. We are not trying to convert, we are trying to convert the conjugate form. Conjugate form is basically the imaginary part is going to be change of sign. So if we have positive, that's going to be negative. And let's look at this one graphically. If you look at the graph for a rectangular form, the graph is going to look like this. In the y-axis we will have the imaginary part, and in the x-axis we will have the real part. Okay, and the distance, this when we write something like a complex number in rectangular form, we are looking at the location, like exact location. So here this is the conjugate form is going to be x in the x direction. So in the real one we have x, so let's say this is x, and in the imaginary one we have negative y. Negative y mean it's going to be somewhere in the down, like in the negative y-axis. So let's say it's somewhere here. So this rectangular form is representing this location, but when we convert this one into polar form, we are looking at the distance from here to here, and also we are looking at the angle that is making with the horizontal. Okay, so usually the standard form we always go from like counterclockwise from here to here. In that way it will positive, but if we go in the clockwise, we have to put a negative sign. So that's why we are going to have negative theta for this one. Okay, and if we write this one, like for this one we have to know one thing: this is r, this distance we call this one r, and this r can be calculated using Pythagorean theorem. That's going to be equal to this opposite square, and you know Pythagorean theorem, right? This is this distance square plus this distance square, square root, so x square, and when we square we are looking at the distance, so this is going to be just y, and y square, and that's going to be equal to r, and e and j, the angle is going to be negative theta since this is in the opposite direction. And also if you want to like express the angle in terms of, like if you want to know the angle mathematically, you can say. And also you have to know another thing, that in the y-axis we are going to have a cos theta. If we say this is real part, this is going to be a cos theta, but in our case this is going to be x cos theta, and y part will be y sin theta. Cos x part will be cos theta, and y part will be sin theta. So this is going to be r cos theta, and if we use this one tan inverse to calculate this angle, tan inverse is going to be r cos theta, r sin theta over r cos theta, r sin theta over r cos theta, and here r cos theta is going to be equivalent to this distance, that's x. Okay, here let's write this one with a different color. R cos theta is equal to x, and r sin theta is going to be negative y. R sin theta is going to be equal to negative y. So this tan theta is going to be r sin theta over r cos theta. R sin theta is negative y divided by x, that's equal to theta. Therefore theta is going to be equal to tan inverse negative y over x. So from this one, so this is basically we are looking at the conjugate form. So for conjugate we have to put it like this, and this is also conjugate form. So r conjugate is going to be r, and here theta conjugate is going to be negative theta, because this is going to be negative tan inverse y over x, and that's going to give us negative theta. So since we know the r conjugate, theta conjugate, we can express the final answer as w conjugate in polar form. It's going to be r e power negative j theta, and that's going to be our final answer. I hope this helps. Thanks for watching.